Hello, here we are in the last section of chapter 1, and it's the distance and midpoint formulas, and we're talking about the circles. And so this section, you basically have to know some formulas, and on the formulas, you got to know how to manipulate them, calculating them, okay, moving terms around, okay, and being able to identify key items on the formulas. Alrighty? So again, make sure you're taking notes. So let's begin this. The objectives, we're going to find the distance between 2 points. Okay, so you got 2 points on the Cartesian plane. We're going to use the distance formula, which by the way is from the Pythagorean theorem. But the distance formula just finds the distance between those 2 points. So it's like taking a ruler and taking those 2 points and measuring the distance between them. We're going to do this without having to deal with a ruler. We're going to just use a formula to find that distance. We're going to find the midpoint of a line segment. So same thing, if you have these 2 points, you're not going to find the distance between the 2 points. You're going to find the point right in the middle. That's called the midpoint. We're going to write a standard form of a circle's equation. We're going to give the center and the radius of a circle whose equation is in standard form. We're going to convert the general form of a circle's equation to standard form. And then when we do that, we can identify the center and the radius of that circle. Okay? So general form to standard form. We'll talk a little bit more of that when the time comes here. All right? So these are the 5 objectives that we're going to be doing from this section. So the first things first, the distance formula. The distance d between 2 points x1, y1 and x2, y2 in the rectangular coordinate system is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, first things first, okay, if you look at these little subscripts, this really gets some people because of the subscripts, x1, y1. They pay way too much attention to that. Basically, you have 2 points. And they don't just say, they don't give you 2 points and call it xy and xy because they could be different numbers. So the subscripts indicate these are both x coordinates, but they could be different numbers. So x1 and x2 are both first coordinates in the Cartesian plane, but they could be different. So the subscripts indicate that they could be different numbers. Same thing with the y's. Okay? So the difference of the x's, guys, okay, that's how far the x coordinates are apart. So if you have these 2 points, if you create a triangle off of that, the difference of the x's is the length of one of the legs. x2 minus x1 is the length of one of the legs. It's the span of the x. And on the y's, when you go up, it's the difference of the y coordinates. That is your b. Okay? So you remember the Pythagorean theorem is a squared plus b squared equals c squared. Well, the a is the x2 minus x1, and the b is the y2 minus y1. And if you look at the radical and get rid of that radical by squaring the other side, the d squared is in place of the c squared. So if you put the Pythagorean theorem right below this, c squared equals a squared plus b squared. The a squared is really the x2 minus x1 squared. The b squared is the y2 minus y1 squared. And then if you square the other side on the d, you have d squared. And the d squared is in place of the c squared. So what I'm telling you is the distance formula is, yes, it's a new formula, but it's basically just a subset of the Pythagorean theorem. So it's developed from the Pythagorean theorem. That's where it comes from. So it's kind of a reissue, if you will, of the Pythagorean theorem. Okay? So, and if we look at this, we're going to compute the distance between the 2 points, we're going to find the square of the difference between the x coordinates plus the square of the difference of the y coordinates. And the principal square root of this sum is called the distance. So they're trying to reword or put into words the formula. So this is the wording form of the formula itself. All right, let's look at an example of this. So we're going to find the distance between these 2 ordered pairs, -1, -3, which by the way is in the 3rd quadrant, and 2, 3, which is up in the 1st quadrant. So you got these 2 points. Okay, we're going to find the distance between those 2 points. Okay, then we're going to round that to 2 decimal places. Okay, so there again, solution is the square root of the x2 minus x1 squared plus the y2 minus the y1 squared. So there's basically two challenges here. One challenge is remembering the formula. Okay, that's the first challenge, is to memorize the formula. So right now you need to be writing that formula down, so on some kind of an index card or something to have that number, this formula memorized. That's the first challenge. The second challenge is putting these numbers in the appropriate place and doing the calculation to get the final answer. So the first challenge is if you don't get that one right, then nothing else really matters, does it? Because if you mess up on the formula, then you're putting numbers into a wrong formula, then of course that's going to be wrong as well. So you got to get that first challenge down correctly, okay? And you're like, well, how can you mess that up? You would believe how many times people will annihilate this formula. They will forget to put the squares. They'll do the x2 minus x1, and they'll forget to square it. And the same thing, or they'll put a minuses everywhere. Instead of a plus between them, they'll put a minus between them. Sometimes they'll do x2 plus x1 squared. So there's a lot of different things that people do to just annihilate this formula. And of course, if you write the formula down incorrectly and you try to use it, the incorrect formula, nothing really matters from that point on because you're using a wrong formula. So, and of course your final answer is going to be wrong at that point. So this is the first challenge. You got to get that right. So we put these the numbers in. So what are the x-coordinates? Well, the x-coordinates are 2 and negative 1. So 2 take away negative 1 squared. Plus, now the difference of the y-coordinates, 3 take away negative 3 squared. So here comes the second challenge, is can you manipulate numbers? Okay, you're like, oh yeah, sure I can. Well, what is 2 take away negative 1? Some people would say 1, but it's wrong. 2 take away negative 1 is 2 negatives and make a plus. And you can't be careless here. You got to take your time. I mean, if you don't know what 2 take away negative 1 is, put it into a calculator and figure that out. But 2 take away negative 1 is 3. And then 3 take away negative 3 is 6. But notice the squares are still coming down with it. Now here's another mistake that people will make. Okay? They'll get to this point right here and they'll say the answer is 9. And that answer is wrong. They're not 9 units apart. You know, why would you get 9? Well, they see the square and they see the square root and they say, oh, they cancel. It only cancels if it's a multiplication. So 3 squared plus 6 squared, you can't just take the square root and the squares and eliminate them. You have to do what's inside the square root first and then take the square root of that. I guarantee you the answer is not 9. But a lot of people would cancel the square root with each of these individual squares and get 3 plus 6 and 9. And they think they're right because 9's a nice number, it's pretty, and it seems to be fine, but it doesn't work that way. Okay? And but you're like, well, what do you do then? Well, you got to multiply that out. 9 plus 36 is, because 3 squared is 9, and 6 squared is 36, and then that's square root of 45. And the square root of 45, and they break that up to 9 times 5, so you can take the square root of 9 and get 3, so 3 root 5. And notice the final answer is not 9, is it? It's 6.71. So if you take the square root of 45, it's between 6 and 7, and so it's about 6.71 to the nearest, and I said round to 2 decimal places. So that's how far to the nearest hundredth those two ordered pairs are apart. So if you drew this to scale, and on an inch, those two points on the coordinate plane would be 6.71 inches apart. Okay, so there's really, like I said, two challenges. Know the formula, okay? Take care of that one first, and then make sure you're paying it close attention to subtracting the coordinates. Okay, so there's a lot of pitfalls you can make. So some people love it because they love formulas and they can memorize formulas and they know how to manipulate them. And these are easy problems for some people, and for others it's worst nightmare. Okay, because they can't memorize, they have a hard time memorization of formulas. Okay, so you just got to get past it. Alrighty, so that's the distance formula. This is an example of one. Now the midpoint formula. Consider the line segment that has 2 endpoints, x1, y1, x2, y2. Now notice the subscripts there are again. Okay, so that indicates that 2 points are different points on a coordinate plane. The coordinates of the segment's midpoint are x1 plus x2 divided by 2, and the y1 plus y2 divided by 2. Basically, this is what I call the average formula of points, because the midpoint formula is the average of the two coordinates. Okay, so if you get 2 points and you want to take the average, what would you do? If you had an 85 on one test and a 95 on another test, how would you find your average? Well, you would add them up and divide by 2. So you'd add 85 plus 95, that's 100, and 180, and 180 divided by 2 is 90. So your average is 90. So that's what that is. Okay, that's the midpoint formula. Now, the midpoint formula is not a distance. You're not getting just a number as far as you're getting another ordered pairs. So that's the difference. The distance formula is actually a numerical value. You're finding it's like a number on a ruler. Okay, you're finding a distance between 2 points. This one is just another ordered pair. So you got these 2 ordered pairs, and you're finding a point in the middle, which is also another ordered pair. Okay, and that point is found by the midpoint formula, and you add them up and divide by 2. So x1 plus x2 divided by 2 is the average of the x coordinates, and y1 plus y2 divided by 2, and that's the average of the y coordinates. Put them together as a point, that is the midpoint. Okay, now again, I've seen people annihilate this formula as well. X1 plus x2 somehow turns into x1 minus x2, or x2 minus x1. And you're like, why would they do that? Because they're mixing it up with that formula there. So x2 minus x1 squared, that's part of the distance formula. But when they get to this one, they want to do the same thing. They want to subtract their coordinates. And when you subtract the coordinates, that's not the average. I mean, think about it. If you make a 95 and an 85 on a test, if you subtract the numbers, 95 minus 85 is 10, and then 10 divided by 2 is 5. So are you telling me that if you make an 85 on one test and a 95 on another test, your average is a 5? I don't think you would like that too much, would you? So the average, think of the midpoint as the average. So add them up, divide by 2. Okay, so that's the midpoint formula. And then we're going to put this in words. To find the midpoint, take the average of the x coordinates and the average of the 2 y coordinates, which is what I just stated. Okay, so again, there's 2 challenges here. Is remembering the formula, okay, and then once you got the formula down, putting the numbers and being able to do that calculation, and then remembering to rewrite it as an ordered pair. So let's look at an example of this. So using the midpoint formula, find the midpoint of the line segment with endpoints 1, 2, which is in the first quadrant, and 7, negative 3, which is over there in the fourth quadrant. Okay, so you got these point 1, 2 in the first quadrant, 7, negative 3 down there in the fourth quadrant, and you draw a line segment that connects those 2 ordered pairs. Well, you're looking for the point that's dead center of that, right in the middle. Okay, so the question is, how do you do it? Well, you take the average of the x coordinates and take the average of the y coordinates. So you add up the x coordinates, 1 plus 7 divided by 2, 2 plus negative 3 divided by 2. Okay, you're adding them up because 2 is the y coordinate of the first point and negative 3 is the y coordinate of the second point. So I'm not subtracting either, guys. That negative 3 is just the numerical value of the y coordinate of the second point. So 2 plus negative 3. So you just do the math. 1 plus 7 is 8 divided by 2. 2 plus negative 3 is negative 1 divided by 2. And then finally simplify. So the x coordinate is 4 and the y coordinate is negative 1/2 of the point dead center. Okay, so 4 negative 1/2 is the point in the middle. Okay, and again, you're like, oh, this is easy. Well, it is easy, except on a test when one problem is the distance formula, the next problem is the midpoint formula, and then you got to keep the formula straight. Okay, that's what makes it that challenge complicated for some people. And some people, it's like I said, it's just straightforward, and it's really easy for them. They love those kind of problems. But some people, they just flounder on them. But you just gotta get past that. Alrighty. So it's part of the challenges of the course. All right. So the definition of a circle. A circle is a set of all points in a plane that are equal distance from a fixed point, called the center. This is kind of the idea of a circle in geometry. Okay, a circle is a set of points that is the same distance on a plane. You're like, why do they put that word in a plane? Well, if you don't put the in a plane, then we're talking about three-dimensional. And then we're talking about a sphere like a basketball. Okay, so that's a sphere. Okay, so if you don't put the word in a plane in the definition, if you just say a is a set of points that are equal distance from a fixed point, and you don't put it in a plane, then you'd be defining a sphere. You would say a sphere is a set of points that are equal distance from a fixed point. But if you add those three words in a plane, then it becomes a circle. And the fixed point that you're in the middle is called the center. And the fixed distance from the center to any point that is on the circle is called the radius. And you're like, yeah, that's all good. I knew that from at least 10th grade because that's when I took high school geometry, and so therefore I know that. But it's been a while for a lot of people, and so, but so there's other things about a circle that we won't discuss so much, like a chord. We don't talk so much about a secant of a circle. Back in geometry, you talked about other terminology. Yeah, we might talk about diameter because the diameter is just basically two radius. It's actually, the plural is radii, R-A-D-I-I. If you have radius is one. If you have two radius, it's radii, R-A-D-I-I. So radius is singular though, okay? So diameter is 2 times the radius. And we might discuss that in some of our applications and some of our problems that we'll see later on, okay? The standard form of an equation of a circle. The standard form of the equation of a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. And you're like, oh great, another formula. Well, it is the formula of the standard form of a circle. That is true, okay? But it is also something you've just seen just a few minutes ago, the distance formula. And you're like, that's not the distance formula. Well, it's close. If you remember the distance formula, it's x1 minus x2 squared plus y2 minus y1 squared equals, and then take the square root of that and equals d. Think about this. For the moment, let r squared be a d squared. And let x be x2, and then h be x1, and so on. And then take the square root and square both sides. You end up with this formula. So the only difference is the h and the k here is the value of the x1 and the y1. Okay, so the hk is the x1 and the y1. So basically, if you have the distance form, you got these 2 points we talked about a while ago. That x1, y1 is a fixed point. You can't move it, but this other point can be moved around, okay? But it's the same distance from that fixed point. So if you've got a point here that's fixed, you've got another point here that's 5 units from the first point, you can find another point that's 5 units from this fixed point if you go around, and that's another 5 units. It could be another one's 5 units over here. So if you let x1 and the y1 be a fixed point, like the hk here is, and let the other point float around this fixed point, and that is your x and the y. So in essence, what I'm telling you here is the reason you had x2 and x1 a while ago is because those 2 points are arbitrary points. Here, the hk is a fixed point. It's a known point. So it doesn't move around, okay, because it's fixed. And then of course the radius will always be the same. So they don't call it d squared. They're going to call it r. So basically, r is the distance that is fixed point is a fixed distance. So that's what we're saying here. Okay, so let's kind of summarize that. Where did the distance formula come from? What did I say a while ago? The distance formula comes from the Pythagorean theorem. Where does the standard formula of a circle come from? It came from the distance formula. So the Pythagorean theorem gives us the distance formula, and then the distance formula gives us the circle formula. All 3 formulas are really the same formula, just stated in a different way. Okay? So that's the thing, is they're just stated in a little different notation. Okay? So finding the standard form of a circle's equation. Okay, so We're going to write the standard form of an equation of a circle with center 0, -6. That's your h and your k. H is 0, and k is your -6, and the radius is 10. So it's just a matter of dropping it into the formula. X minus h squared plus y minus k squared equals r squared. Okay? So what is h? Well, that's 0. What is k? That's -6. And what's r? That's 10. Well, let's just drop them into the formula. X minus 0 squared plus y minus a -6 squared equals 10 squared. And then all we got to really do is simplify that expression and leave it in that form. Well, so what's x minus 0 squared? Well, that's x squared. What's y minus a -6 squared? Well, that's y plus 6 squared. And what's 10 squared? That's 100. So we have x squared plus y plus 6 squared equals 100. Alrighty? So the standard form of the equation of a circle is x squared plus y plus 6 squared equals 100. So this is about as easy as it'll get. So really there's only two things you have to really do. Know the formula, drop the numbers in the appropriate place, and then from there on just clean up the math. Like 10 squared is 100. Y take away -6 is y plus 6. So it's really quite simple to do. Okay? But again, if you don't know the formula for the standard form of a circle, then you can't go from there. You're stuck before you even start. Okay? So you have to know the formula. So again, what I'm telling you here is when you're taking notes, box in these formulas. Put down the distance formula. Put down the midpoint formula we just discussed. Put down the circle formula. And then you just have to memorize them. So, and then when you take your test, first thing I would do is put all these formulas on my test in upper margin somewhere, out of sight. But and then memorize them in that way, because that way when you're doing your test and you do one problem 1, 2, and 3, and you start getting flustered with one of the problems, then you start losing what you memorized. So you don't want to. So you want to write these formulas down on your margin before you possibly get flustered. So if you get flustered and then write the formulas down, then that becomes problematic. If you get flustered on one problem and then you already have the formulas down and you get to another problem and you say, oh, I got to know that formula, and you can refer back to it that you've already written right when you got the test. So just a trick of the trade of math test taking. So, all right. So, example, using the standard form of a circle's equation to identify the center and the radius of the circle. So find the center and the radius of a circle whose equation is in this form. So this one's a piece of cake, okay, because it's already in standard form. So you can identify the h, and you can identify the k, and you can identify the r squared. So the solution here, the center is -3, 1. You're like, why is that? Well, because remember, it's x minus h. So minus h equals 3. So if minus h equals 3, then h is a -3. And then minus k equals a -1. So that means k is 1. So the center is -3, 1. Now remember, r squared is the number. So the radius is not 4. The radius is not 4. Okay? The radius squared is 4. So square root of 4 is 2. So the radius is 2. So you have a center at -3, 1, and it's a circle around that point that's 2 units all the way around. Okay, so the radius is 2 units. So, and like I said, this one's a pretty easy problem. I guess probably the two hardest things that people will mess up on is they will tell me the radius is 3, 1. Because they see a 3 and they'll see a 1. But it's not 3, it's -3, because remember it's in the form of x minus h squared. So minus h equals 3, which makes h equals -3. And another mistake people will make, they'll just say r is 4. They'll see that number on the right side and identify that as the radius. And it's not, that's the radius squared. So to get the radius, you got to take the square root of whatever that number is. Sometimes it's not so pretty. I mean, sometimes that number's not 4. It could be a 7. And so the radius would be the square root of 7, which is not a nice number. It doesn't come out nice and pretty. Square root of 7 is about, what, 2.7 or 2.8 or something like that. So it's not exact. So be careful in those situations. So, alrighty. Now the general form of the equation of a circle. The general form of the equation of a circle is x squared plus y squared equals dx plus ey plus f equals 0, where d, e, and f are real numbers. Okay, so this is the general form of a circle. When you get it in general form, just look at, I just want you to remember this. It's bad news. Okay? And the reason it's bad news is because when it's in this form, you can't just simply identify the center and you can't simply identify the radius when it's in this form. So, but this is general form. So if you take standard form and FOIL the two expressions out on the x minus h squared and the y minus k squared, and you just FOIL both of those out and combine all the terms you can combine, you will get this form. Okay? So if you go from standard form and just multiply it out, and you'll eventually get this. But the trick here is when it's in general form, how do you get back to standard form? Because when you have an equation of a circle, the things you're going to want to know is the center and the radius. You're like, why would you want to know those? Because you're going to eventually want to graph these things. So in order to identify the center and the radius, you're going to have to put it in standard form. To do that, it's going to require you to do something you've already done, and that's complete the square. But you're going to do it twice. Okay? So let's look at this example. We're going to convert from general form to standard form. So we have x squared plus y squared plus 4x minus 4y minus 1 equals 0. So we're going to complete the square for the x's, and we're going to complete the square for the y's. So what we do is we put the x's together, x squared plus 4x. So I just rearranged some terms. And then y squared minus 4y. And then I took the 1 to the right side, and I'm just going to put it to the other side because it's not going to be, in effect, it's not going to be helping me out with the completing the square. So do you remember how to complete the square? If you have x squared plus 4x, remember you've got to take half of the 4, which is 2, and then you square it, and that's 4. And then you look at the next one, negative 4y. Take half of a negative 4, and that's negative 2. But when you square that one, it's also 4. So look at the next step. X squared plus 4x plus 4, because that's going to make that a perfect squared. Y squared minus 4y plus y, that's going to make that one a perfect squared. But notice on the right side, I have my 1 that I already had over there, but I added 4 twice. Do you know why? Because I added 4 to the x squared plus 4x plus 4 to make that, add that 4 to make that a perfect squared, and also on the other one. So I added 4 twice on the left, so I have to add 4 twice on the right. Now, x squared plus 4x plus 4 will factor, and y squared minus 4y plus 4 will also factor. So x squared plus 4x plus 4 factors to x plus 2 squared, and then the y squared minus 4y plus 4 factors to y minus 2 squared. So, and then why is that 9? Because 1 plus 4 is 9. So can we identify everything? Well, look at the graph. The graph is negative 2, 2. That's the center. Because you go left 2, because x plus 2, the opposite of 2 is negative 2. So then you go left, then up 2. And look at the little red line segment that's referred to the radius. Can you count those units? It looks like it's 1, 2, about 3 units to the right. That makes sense. Why? Because r squared is 9. So the center of the circle is negative 2, 2. And the radius of the circle is the square root of 9, which is 3. So that is how you go from general form to standard form. Now, to be quite honest with you guys, in my opinion, okay, this is the hardest problem in this section. The distance formula is pretty much straightforward, the midpoint formula as well. Standard form of a circle is fine if it's in standard form. But when it's in general form, that's the toughest thing because you have to complete the square twice in order to get it in the standard form. So you got to be very patient with your calculations. There's a lot of times you can make a mistake there in adding the wrong number. Okay, so in completing the square, as we all know, is not always an easy thing to do. And not only that, you're doing it twice in the same problem. Okay, so if you're not going to write anything else down, write this problem down right here. This is going to be probably one of the toughest problems in 1.9. So It's very straightforward here, and they could have made the numbers a little different. I mean, if I was the author of this book, I would have made the negative 4y a negative 6y just to make the numbers a little different. But the reason they did it this way is they wanted a nice radius, and the radius was 3, and so he designed it this way. Alrighty. So, but anyway, so that's this section. That's 1.9. It's the final section of chapter 1. We're going to be moving into chapter 2 on the next section, and I'll see you there. But I'm just going to remind you now, you guys, when you're doing your problems, you run across something, send me an email, and I'll respond to it, and I'll let you know what you're doing wrong, and we can fix what you're having troubles with. So, but like I said, I'll see you in the next section, and you have a good evening.